Hi, this is Rajiv. I would like to thank you for watching this video. In this video, we'll have Beate Porst, the Offering Manager from IBM Information Server, talking about the future roadmap for Information Server from a data integration perspective. So let's hear Beate talk.
Now let's look at the what are we doing next with Information Server. And again, the viewpoint here is more towards what are we doing on the integration side. This doesn't mean we have no roadmap on governance and on quality, quite the opposite. There is, if I would cover that, we probably would have needed double the time. So, and my immediate responsibility is obviously on the integration side. So I wanted to share this one. And if there is interest, we can find another time to cover the governance and integration that has an equal amount of things that we are planning to do in the next 12 months, 24 months, or whatever time frame. All right, let me go into. So some of if you look at what we've done on in the last 10 months for Information Server, then you basically recognize some of these development principles or priorities here. They continue to be our key priorities as we move forward. So these are all around simplifying our products and simplifying it from a usability point of view, but also from an accessibility. So the clear direction, as you have seen here, is to move away from a thick client. We want to eliminate that tier, that client tier, as a mandatory part to actually run some of our components. So we want to have a much lighter weight access route, and that is in line with some of the direction that we have to make our offerings available on the cloud. And the last thing we want to have to deal if you you know, find Information Server on a marketplace is at the next step to have to install and find a Windows client. So the need, there is an instant need here that if we want to make our offering available on the cloud, then we have to have thin client environments to work with. And so this is a good double side here to focus on making it easier to use, as well as giving you easier access to consume it in the first place. The second one goes with that. It's around the automation of steps. It's not just to make the product simpler to use, but at the same time, we want to automate more of the steps that you needed to do explicitly in the past. And that is applying basically through all the capabilities that we have, whether it is around the governance side or the quality side, but equally in the integration side. We want to understand or go to a point where we know exactly what kind of integration you want to do and generate it for you, rather than you having to build it out. So this kind of instant integration is some of the critical parts that we are looking to build out into the product, that it becomes really quickly to move data in any kind of fashion. Another focal point for us is the support of multi-cloud. If we, when we studied clients and where they want to be, most of our clients have some route to the cloud, but it's not so that it says, oh, we are only going to IBM, or we only go to Amazon, or we only go to Microsoft. Often it is kind of this mix of all of them in some form. While at the same time still having certain data sources on premise. So you have a relative complex environment now that we need to operate in. And specifically when it comes to integration, that is a fairly significant or a more complex environment than what we already have if we only are on premise. So not only do we have to deal with the complexity of data sources itself, now we have the complexity of having these data sources on some cloud environment that may be located in Australia, where the data center is in Chicago or so, right? So there is a long distance network in between, and how do you deal with that if your data volume is many, many terabytes of data? And last but not least, the composition here. And composition means now that we have started out building out containers for our platform, that's actually not enough for us to say we stop here. We really want to look at saying, what is the right level of microservice enablement? The really promising part of these containerization is to say, I can compose an architecture based on these microservices and based on my business needs. And so where we are right now is so that we still need to build these containers much more in a microservice-based architecture than what it is today. So there are a lot of things that we want to do from an architecture that are fitting better into the containerized microservice-based architecture model. With that, with these key priorities, the next one, and that's directly coming out of this composition of services, comes that if we build our platform in a way that we have much more fine-grained individual services, each one representing here a container, we actually can compose a deployment in a much better way. And our ideal or the direction that we have is to build out a microservice-based architecture for not just for information server, but for the larger unified governance and integration side. So the work that we are doing for information server, we do similar work with our partner teams for master data management, for lifecycle governance, and each of them contributing services here that can be composed. In the center of these sits the smart metadata part, and the smart metadata comes from information governance catalog and this knowledge graph and another component called the Watson knowledge catalog. So we recently actually formed a or rejoined with our partner team from the cloud side, the Watson knowledge catalog team, to build this smart metadata environment. And each of these services that is surrounding the smart metadata is really utilizing the metadata that are stored there. Whether we do data quality analysis or data integration or data preparation, each one has an access and has access as well as contributing to the metadata that is available in here. And so you may want to, okay, so what is so much different from information server today? From a principle, it is not different in terms of that we have shared metadata. What is different is you don't have to have a monolithic platform. So in that sense, information server is still a relative monolith. In the future, these are more individual services, and you don't have to have all of them. You pretty much instantiate individual containers at a given time, and next time you instantiate a different set of containers. And that is one of the fundamental differences. Another fundamental difference is that is a much broader set of services that you have at your possession. So it's not just around quality, governance, integration. There are also these more master data and lifecycle governance related capabilities that are also part of that platform. And last but not least, from an integration side, we are expanding the engines here. So we are one of the large strategic directions that we are moving towards is what we call a data movement strategy. That means we want to treat a certain integration as just independent from how the data is later being moved. So what I mean here with that is whether you want to have an initial load into a database or a trickle feed into a database, or you have a heavy transformation project or a real-time integration, all of them need a certain design aspect, meaning you tell us what are the sources, what are the targets, and what kind of things are happening in the middle. But you don't need to tell us the type of runtime you want to use for it, or what kind of frequency, all of these kind of things. That is something we figure out by having a library of different engines available that we can instantiate at any given time. So this will also be part of this platform. I go into this actually a little bit more, as it is one fundamental aspect that we have here for integration as our go-forward strategy. All right, so the first one I want to actually go into here is around the integration experiences. Previously, I talked about the data stage flow designer as being the landing point for anything integration related. And that's this kind of view here on this slide, as you see here, this interactive personalized experience. And so it really means that if you want to do simple or complex integration, you always have one landing place, and it gives you different perspectives into what you want to do from an integration experience. And you may be a line of business user that really doesn't know anything about operations, whether, you know, a transformation, and doesn't want to care about it. All they want to care is that they know they are looking for a data source, and they want to lend a transformed version of that data source somewhere. Everything else for them is kind of an interactive experience of either asking a question or doing some lightweight work. And the user experience will help them doing exactly this. So they will not be presented with any complex integration design, but rather work in almost what we call a question and answering system of what they need to do in order to reshape that data source. If you are coming in as an integration specialist, you may want to have a very different experience. And you said, I want to see all bells and whistles that are possible, and whether or not I use them, I really want to have them available and take advantage of them. So it's really what kind of role you have. It will give you a different perspective and shape to your particular needs. And as I mentioned previously, underneath that sit around different engine capabilities. From a user design perspective, they don't matter at that point, because only at the time of run, when you actually run the workload, will those engines become significant, whether you have a micro-batching requirement or if you have a long-running, heavy-duty requirement. We will then instantiate the right engine that will do the job in the SLAs that you define. All right. Obviously, in order to do what I just said from a user, there is a lot of things that we want to do to assist in this data integration process. We've started with some of this smart user interface, but that's really just the first step in our journey to accelerate and automate data integration. One of the larger projects that we have going on is what we termed as Shop for Data Integration. And you really think of a shopping cart experience here when I say Shop for Data Integration. It can start all the way by you of describing a certain business problem that you have in a natural language, as an example. And based on that, we will find certain data assets that match this kind of query that you were asking the system whether they have data for that. You then can select these data sources either as a target or as a source or both of them. And we will determine, based on historical data, on learning experiences, how these data needs to be transformed to go from one to another. And we will generate everything for you in an automatic way. So there is really, we want to avoid that someone who has no experience of transforming data ever has to go and look for an operation. So everything becomes fully automated. Part of that Shop for Data Integration is also what we call the data movement strategy. So here it's utilizing heuristics of how would we want to optimize a job execution in a situation where I have data sources spanned across multi-cloud and multi-engine. So how do I know that a job is a job that is an initial load? Or how do I know whether I should use a streaming engine or a heavy batch engine? So that's all what we define here as data movement strategy, where you can define SLAs. So you basically define, you know, this is my SLA for this kind of data. The rest we determine. We know where the data are. We know what kind of network may be between them. We know whether or not we can, for instance, push certain workloads to an engine that runs closer to the data. So there are a lot of decisions and heuristics that we need to bring in to make that happen, to have a single interface that you define it in without actually knowing how or what kind of runtime it will be utilized at the time of execution. I was actually, I was trying to find an analysis of how you could compare this. And one thing that I could think of was if you are on something like Google Maps, and you know you want to go from A to B, and it gives you a routing. But it may sometimes tell you also, oh, by the way, if you hop in a bus here, walk a couple of steps there, then hire an Uber. That is the fastest way to go from A to B. Alternatively, you can just hop in your car and go from A to B, but you may be stuck in traffic for the first 5 miles of your journey, and it will take you a little longer. So this is kind of the analogy here that with this data movement strategy, we want to make give the user an option to take advantage of all the different runtime and integration patterns that are available. There is no need that they need to use any of those. They can still use and apply a traditional method if they want to. So just as an analysis of what this data movement strategy is aimed at. Obviously, it's aimed at delivering data at the right time and in the best method. All right, so this is a different picture of basically it's the same thing of saying we want to optimize data integration in this multi-cloud environment. And there are other things that we will take into consideration. One is, for instance, looking and can we scale up runtime somewhere elastically if needed. There are also other considerations around licensing. If we want to have the freedom of providing burst method and so on, we have to have also a licensing that allows that. In our traditional current PVU-based license, you are confined to a certain PVU level at a time. So you can't just say, today I need to burst to double my engine capacity. If an auditor steps in at the same time, they will certainly slap you on the finger. So these are all things that are taking part of this strategy. Okay, so this is kind of a longer term strategy. This work has started, but obviously it's not all shaping out at the same time. Now look at what are we doing more in the closer time frame. What are we doing till the end of the year? What are we doing in the first quarter of 2019? So we have a pretty significant release plan for the remainder of the year. In this case, we opted not to release another feature pack, but we will release those capability as patches. The reason is here that for us, delivering it in patches gives us a bit of faster route to market because we don't need to combine this and test the entire platform with something that also becomes a full installer. So there will be 2 separate patches, one for connectivity and one for the integration for the design and engine side. So you see here there are a number of connectivity items that are on our list. We finished already the Presto side. So Presto is a method of sort of push down on Hadoop. So it kind of can think of it almost not push down. It's probably more on a federating SQL on Hadoop by having a single relational query that you define in Presto that can then actually target a number of data sources at the back end. Other data sources that we are building connectors out or certifying are for Azure Data Lake, Google File System, BigQuery, and so on. So you see here quite a lot. On the data stage flow designer, again, we want to bring in more capability here, more stages. We want to show you the execution metrics similar to what we do on the thick client, more properties, parameter sets, Bitbucket support. So you see this kind of, and on the engine side, again, it's centered around making us smarter on Hadoop. So a lot of improvements on the Hadoop runtime. One important part that I want to point out here is information server on AWS and Azure. So we will have containers that we have specifically performance tested and build out for AWS and Azure. We've run, since the last 3 months, we've been in performance studies with both AWS and Azure to make sure that our runtime works as good as it can on those cloud environments. We've seen very good results specifically on AWS. On Azure, there has been things that are not related to our software, but to the way how Azure containers are built that are generally for, it has nothing to do with information server, just to set the level right here, but the way how Azure defines containers are so that they use very slow file systems and things that affect the software that runs on top of it, unfortunately. So we are in contact with the Azure support to provide this feedback so that hopefully in the future they will improve their container images to make them more performant. So we can only be as good as the machine images that those cloud providers provide, and so there are some things that Microsoft can improve.
Yeah, I have a quick question.
Yes.
On the information service doctor, what's the topology of those? Is it like, we have multiple topologies for information service install. So what is it a standard set of topologies, or is
yeah, great question. Let me, in case you couldn't hear on the people on the phone, the question is for the Docker deployment for information server, what is the topology? And so we have 3 main containers, a container for the repository, a container for the application server side or the services tier, and a container for the engine. The engine container can scale horizontally, so you can spin up as many engine containers as you like and have them all associated. They can be spun up in a tiered method, so you can have a head node with compute nodes or just clustered. And then this is for the base. In addition to this, we have the container set for the enterprise search that we recommend to put yet on another virtual server or so. And that is, those are a total of actually 30 individual containers. That is the tier that we have really fully microservice enabled, and therefore has a much larger number of individual tiny containers. But from the information server side, these are 3 main containers today. All right, last slide is 2019. We do plan on having a new release for information server in the first half, ideally actually in the first quarter. It will be a minor release, so it's not, a minor meaning it will likely be a dot release on 11.7, meaning which is good because it really fits into the continuous engineering concept that we don't want to have big bangs or so, but give you continuous content into it. And so it gives us the ability, or it gives you the ability just to install it similar to a feature pack, but getting actually a new release cycle here. There are a number of things that we plan on rolling into that. I think from an integration point of view, for me, one part that I'm looking forward are data stage on Spark. As I mentioned, we want to give you more engine options, and data stage on Spark is one of them. It is so that we want to use dedicated pieces for Spark. So we want to actually, as I said, combine PX with Spark. PX for the strengths that PX has, Spark for the strengths that Spark brings with that. And in cases, then combine the 2 of them. So that's something we still plan on a preview actually in Q4, still figuring out of how we can enable the preview without having actually a release. So still some consideration how we can this tech preview bring to our users who want to see it. Another part that I want to bring in is what we call Agent Stellar. I didn't talk much about Agent Stellar. It's actually something that our engineering team came up on their own, but it's actually such a cool little, it's not little, but it's a nice feature. So the idea here is, think of it, what many of you use Alexa. And so Agent Stellar is not where you speak in, so it's actually something where you type in, but we want to connect this to the Watson knowledge center, not center, but the ability to look up information, but train it specifically on information server. So for instance, if you ask it things like, what is this error message telling me? That we find this information for you. Maybe you're looking up, oh, there was a support case open for it. Here is the tech note, here is the APAR, and so. Or some other things, really, you do something and run into a problem, and you can ask it a question saying, tell me something about that problem. It's really an active help environment that Agent Stellar represents here. Huh?
Out of my life.
Yeah.
So is that going to be free programs, I guess, say, with Knowledge Center?
Yeah.
APAR, all the
Yeah, so we will train it more and more. So it will initially be more on, tell me what feature level I am in, what kind of error do I see, and eventually hook it up to more of, a Watson kind of integrating into the Watson service to obviously we don't intend that then you said, hey, Stella, tell me what the weather is, but in theory that could be then. So that's something. Also, the business user driven preparation curation is something we want to bring into. And then in the second half, it's more about what I told you around this data movement strategy. That's really the first instantiation where we want to have this, that you build a single integration design, and we figure out for you what's the best route here for you to run it on. All right, so I think I hope you see there's a lot of things that we want to make information server really a smart integration system, and not take the, I know as a business partner you want to do work for your clients, but we want to make our clients, or enable our clients to get things done really quickly.